I have 4 things to say. This is very tough because people are from UB Summit looking at the business opportunities, but again, sorry, this is more fundamental issues I'm listed, 4 of them. One is global ubiquitous network environment. We have separated ubiquitous networks, many in Helsinki, many in Seoul, many in Tokyo, and many in many other places, but we don't have a federated ubiquitous network. And also, we don't have a self-organized, self-optimized, self-monitored, self-repaired network yet. So we need some kind of nice model and theory. For the business people or for the systems people like us, we need an international global ubiquitous network testbed. Many years ago in the US, DARPA set up something called Urban Challenge. So they are testing the autonomous land vehicle in real settings. We really need Urban Challenge for global ubiquitous network. The second one, distributed smart architecture. This is related to more different types of ubiquitous devices or node became available. We need to connect with the cloud. So this is a picture, assuming that we have a global ubiquitous networks, and then we have many sensor networks, information appliances, network robots, many web services, real space ITS, and SNS, and so on. These things are coming into the global ubiquitous networks, and then we somehow utilizing the cloud. I put the C class. C stands for context cloud, and then somehow we can share a large number of user profiles, service profile, context profile, and so on. So this is one big issue. In terms of architecture, we need to create a scalable architecture. By looking at this picture, one of the challenges, where shall I put the code and data? Placement of code and data and placement of profile and context is the key issue. If you are creating very optimized architecture, we have to find out the best place for putting the profiles, context, code, and data. Another one would be dependable architecture, more critical applications with the context awareness. And third, we need strong coupling between cyber and physical space. We need some kind of, not only just the user behavioral modeling, but if doctor is doing some surgery, we need some kind of real-world modeling to support the human activities. So this kind of cyber model have to be created. Okay, third one is the cross-domain service coordination. I show you the picture already. We have many different kinds of services available, but unfortunately, even in, let's say, home appliances, many different companies prefer different protocols. So unfortunately, we have many devices, but these protocols are partitioned in a vertical fashion. We cannot connect services across the domain. The web services are very nice. They can harmonize different types of services very easily. Let's assume you put the robot into there. Okay, you're trying to find a robot who can greet you, or who can pick up some of the items, heavy items for you. Now you need some kind of timing attribute which says, well, I can move at least 20 kilometers per hour, or I can lift it up in 5 seconds, or in a second, or in 0.1 second. So the web service is nice, but doesn't have any temporal specifications, so you cannot quite mix up with the robots yet. Okay. So we need ubiquitous and universal service description, or new type of human service interaction method, and so on. Okay. So this is an example of robot. Actually, a friend of mine at the ATR trying to exercise with new robot services. This is very interesting. Robot trying to find out who is my customer, namely looking for something. So robot trying to find out the customer and then trying to say, may I help you? All robot have to do is, may I help you? Okay, let's see. So that's something, there are a bunch of sensors, and then robot have to coordinate with the different sensors. And it's very difficult to define the behavior of that guy. Okay, fourth one is the technology shaping and social innovations. I think people here in Finland, same. In Japan, when you look at the robot, I cannot bring the robot in a public space if that robot can move more than, say, 30 kilometers per hour. Our traffic regulation was designed in Meiji era, and then everything was vehicle. Only vehicle is defined in that regulation. There's no robot. So we talked to the government many, many times, and then maybe 4 years ago, they agreed to create a special regulation. Say, if you can submit the request in advance, okay, 2 weeks in advance or something, to a police station, say, I'm doing an experiment with a robot which go around the public street. Then big cities, small cities, they can accept some of the things. Okay, but anyway, this is another example. My colleague, Professor Yamanaka, created this nice video. Assuming that you create a new technology, which is this very simple RFID card, and we're trying to get into the train station. We have so many people are coming into the train station. They really would like to utilize this card. All you have to do is touch and go. But when a new technology was introduced to Japan, not many people are ready to do. Okay, so let's see how this experiment went. So, towards the 2015, I mentioned the 4 challenges. One is the global ubiquitous networking, and then we need a smarter distributed smart architecture. We need a cross-domain service coordination, and technology shaping and social innovations. I think one of the challenges here is people here are creating the very nice new technologies, but as you can see in the last video, we have to understand how people are accepting the new technology, and then similar to the robot, we have to change the social regulations so that we can actually adapt more nicely. And then I hope that this Ubiquitous technology will provide the empowerment of people, organization, community, and space and environment. Thank you very much.